Boom! Look at that. Look at those pros right there. Not like that other show that I do. Oh, hold on. Looks like I'm totally cranked up too loud there. Let me drop it down a bit. There we go. That's better. Sorry about that, kids. We're pros except for the volume.
Yeah, that's a little iffy.
A little iffy. How you doing, Camel?
I'm doing pretty good.
Which we're going on right now?
Well, right now I'm looking at what we did last time. And we added an error system, and we found a way to operate two fractions together that had already been kind of operated on.
Oh, I see. Okay. Cool. Let me grab this. I'm going to pop this in the chat room for anybody watching. There it is right there. And in the chat room, if you want to go get the source code. Kind of an interesting project we're working on. We're creating kind of this idea of a supercalculator and a SuperNumber. So a number that can hold a fraction.
Yeah.
Right? And
pretty much.
We initially started with hey, we'd like it to be a fraction plus units, but we've never gotten around to units, putting units inside of this.
We have not, no. We could do that today.
We might do that today. But right now we have a SuperNumber. What can our SuperNumber do?
It can take fractions, and it can multiply them times each other. It can divide them by each other. It can subtract two fractions, or two mixed numbers, or a mixed number and a fraction, or even a decimal.
Right.
And a fraction, or a decimal and a mixed number, or just things like fractions, decimals, mixed numbers, impropers, propers. Right. It can pretty much do anything with any of those.
One thing I wanted to point out is with the way operators work, divide and minus are order-dependent operations. 1 divided by 3 is not the same as 3 divided by 1.
Yes.
And 1 minus 3 is not the same
as 3 minus 1.
Right. So when we're talking about add and multiply, we can say we add them together or we multiply by each other. When we're talking about divide, we wouldn't really say we divide them by each other. We would say one is divided by another. Or same thing with subtract. One is subtracted from another. But yeah, no, that's right. That's what we did yesterday. I thought you did a great job summarizing that. And we added some cool test cases. You want to show the test cases we added?
Yes. So we added test for nums. Wait, let me. There's in fractions test. Yeah. So we have all of these where it's basically we have a fraction, any operator, another fraction, and then we're trying to see is that equal to another fraction or a whole number or mixed number, any operator, and then another whole number, mixed number, fraction, decimal.
And for anybody who doesn't quite understand what's happening when they see a string followed by a dot eval.
Oh yeah.
Can you explain what's going on there?
So this is it's our new system kind of. So we have a string with any of the mixed number plus this or mixed number divided by this. And then our dot eval, it's a method that we have. Wait.
Remember what kind of method it's called?
It's an extension method.
Extension method. That's right.
So this is the method right here. It takes the string we pass in.
Do you remember what I'm sorry, go ahead. Do you remember what the keyword is that differentiates an extension method from a normal method in terms of the way it's declared?
This.
It's that keyword right there. So that keyword shows up in front of the very first parameter. Only the first one. I can add more parameters if I want. Watch this, by the way. Let me add one quick parameter here. We'll type in VI to create an int parameter here. We'll just call this P2, like that. Now if we go back to eval, watch this. We can push in a number into it like that. See what's happening?
Yes.
And what will happen is that will go to the second parameter. What happens is this goes to the first parameter. Does that make sense?
Yeah.
Okay. Just want to make sure that's clear. All right, we're going to go ahead and undo that, and go back and undo this. So yeah, it's kind of cool. You can create custom methods on any class instance, on any instance, even if you don't have them, that instancer. You okay, buddy? Do you need like you need to go wash your eyes or something?
No, I think they're fine. They're a little bit itchy.
Itchy?
I think it's okay though.
Let me know if you need a break. I got this button. I got this killer button here. Want to see it? Watch.
Okay.
That's the killer button right there. Okay. Well, I'll tell you what I want to do. I said this at the beginning of the show to you, or just before we started. What I want to do is I want to. Am I going too loud again? Hold on.
Interface.
Test. What I want to do is I want to change the user interface a little bit. Let's do that. Let's do the interface. Let's work on the user interface. And I'll show you what I'm thinking about for it. Let's switch to Solution Explorer. And there's our main window right there. And I want to take all of this out. I originally was thinking, oh, we could put up here the numbers as you fill them out, and then choose the operation, but now we can do all of that in text. So all I'm going to do, I'm just going to delete all of this. I'm just going to radically change the whole user interface.
Yeah.
That should get rid of everything but the 2 lines. 2 lines. Then I've got a TBX. I don't even need this TBX here. What I do need is a label to show the answer. I think it's just L. It's for label. So we say LBL answer, like this. And I'm not going to set anything for it right now. Okay? So that's going to go right after it. But I will maybe change the font size. Wait, let's just try a second. Let's see how big it shows up. Hello? Yeah, it's big enough. Okay, we're good. All right, so we'll just set content to nothing there. So, and I'm going to rename this. Let's go rename this one first. Rename that to TBX equation. So we're going to type something in at the top. And whatever you type in, we're going to kind of answer it at the bottom. That's kind of what I want to do. Does that make sense?
Uh-huh. Okay.
And then rename this to TBX equation as well, like this. So now we got something slightly different here. Now we do have, we still need a number or the equation. We still need a number or an equation. I think like that. Down here we got problem because we got this weird thing that doesn't exist anymore. So I'm just going to delete that whole method. Okay, so I've got that property out there called content. Label whatever content. I'm going to create a method, call it set answer, and it's going to take a string. Call this answer, like that. And then what I'm going to do is I'm going to say LBL answer.content equals answer. Okay?
Okay.
And then here, I'm going to, instead of saying the title's equal to that, I'm going to call set answer. Basically say, hey, enter an equation above. Like that.
Yeah.
Okay?
Okay.
And maybe we'll start with that as well. We'll initialize the form with that value right here. Okay?
Okay.
All right. I like this interface better. Now, once we get to the point, and notice we got right here, equation, we're calling toNum on it.
Yeah, toNum is our other extension.
That should actually work. Now, once we get to that, we'll come in here and we'll say, hey, if SuperNumber.type is a fraction, can you finish this code for me?
Yeah.
SuperNumber.type is, look at what was that, look at what was suggested though. Go back to what was suggested at the beginning. Go back one more and then hit the space again. See what happens. Look, it's suggesting number type.
Oh, number type dot fraction, right.
It's a Nina. Okay, go to the next line. Give me the letter B to give me a block
Space?
there. Yeah. So the number type is a fraction. Then I want to say LBL answer. Oh wait, no, I'm sorry. I want to call set answer to SuperNumber dot toString, I think. Because I think toString, we wrote it so if we look at our toString override in this guy right here.
Yeah.
Oh no. That's not right. I want to do this. And type, maybe you could do this. Add some code to check to see if the type is a fraction. And if it is, give me a different string coming out of here that represents the fraction, not the value.
Okay. Oops. Ah.
You can do it that way.
Really? Would that work?
Yep, you can do. It doesn't matter which side of an equal sign.
Oh, right.
It is just checking to see. But for readability, I like to put the thing I'm testing on the left always. So what I would do is delete all this, control left, and then say type equals, double equals. It's just type. Remember the property we added here? Inside the class here, SuperNumber.
Oh, right.
Tap, control, oh there it is, you can see it, you can find it right there. Let me show you something. When we're here, if we're looking for a property, see it says tap control for options, tap it, then hit the letter P. And these are the properties we have. Denominator, numerator, remember we added the sub property?
Yes.
Sign, what's that?
It's, that takes the operator, is that right? Or, no wait, it takes, sorry, the operator on the number. So like, if it's negative or positive.
If it's negative, what is the value of sign?
It's false, right? Or no, it's not. It's an int.
It's not a Boolean. Sign is an int. It's going to be a number. What is it if it's negative?
Right. It's -1.
Right. And if it's positive, what
positive,
is it?
It's 1, and if it's 0, it's just 0.
That's correct. Exactly. So that's sign. This is also those three numbers are consistent with a programming function called math.sign, which asks the same question.
Yeah.
The cool thing about giving you a -1 or a 1 is because that's the identity property. I can multiply anything by the sign, essentially, and it won't change the magnitude of the number.
No.
It'll just change whether it's positive or negative. So it's much better than like saying, well, I'll give you a -3 sometimes if it's negative. Do you know what I mean? By saying it's always going to be a -1 or a 1 or a 0. So we're doing that exact same thing there. What's type do?
Type, it gets the type of the number, so it figures out if it's a decimal or a fraction.
Right, and we hold on to fractions as long as we can. But if you multiply a fraction by a decimal, you're going to get back a decimal.
A decimal, yeah.
Okay, but if you multiply by fractions or divide by fractions or add fractions, we will continue to hold on to fractions. That's the cool thing about this. So if type is equal to fraction, I want to put out a different string. I also had a dream about this, Campbell. My dream was change this to SN. Like that, so it's smaller and shorter. What am I going to do here? I want this thing to look like a fraction. Can you figure that out?
Yeah, I think I can. I think so. Oop, wait.
Tap control and hit P if you want to see only the properties.
Oops.
For example, if the whole number was 1 and the denominator was 2 and the numerator was 1, I'd want to see 1 space 1 divided by 2. Does that make sense? Let me just write that down. I want to see like 1 and 1/2 if as the answer to that, for example, as a string.
So
there you go. Hold on, go back. Get outside of this. You're in the interpolated part. This can only do one value at a time. Now you want a space. See what's happening? See how they're connecting up with what we want? All right.
Nope.
It's close. It was just one down from that. Control space would finish this way. That you want. There you go. Good.
And then here over denominator. Denominator.
Okay? Get a semicolon at the end. You can get rid of that in my comment if you want. Good.
Actually, wait. That was decent to show what it was doing.
Sure, go ahead.
Oops.
1 2/3 or something. Horrible. What? Okay. That's what we're going to put up. So SN. Maybe we just take away the SN. No, wait, I have an idea. Hold on. Let's do this. Let's create a property type string. Oops. Actually, let's create a read-only property type string. Like that. And we're going to call this display start. Like that. And what we're going to do is from here, we're going to simply say return my display string. Like that. Okay, so toString, this is used for debugging.
Yeah.
But if we want to actually use it in the user interface, I want to do something like this. Hey, type is fraction, do that. But instead of doing this SN in parentheses, we're just going to do it like a normal display string. Otherwise, return value toString.
Yeah.
Okay?
Okay.
I like that better. Now what we want to do is use display string over in main window. So instead of calling toString, can you call display string there? Remember, control shift left and right arrows can get you to select that much faster. Also alt and left and shift right arrows. All right, good. There's display string. Can we save it? Oh, it's stir at the end. Save it. Run it. Oh, it's not a method. It's property I added. So you don't need parentheses.
Okay.
Good. Save it. Run it. Moment of truth, kids. Enter an equation above. What do you think?
I think I was talking to you about this yesterday. I think that what we should do if we have like 5 and 0, 0 over 1, we should just convert it, or 0 over anything, we should just convert it into this as a decimal.
What about instead of doing that, because I think it's still useful to hold on to it as a fraction, what if instead of doing that, we change our display stir method. So that instead of displaying it, if that's 0, we just don't display the fraction.
It just wouldn't show it. Okay.
Can you write that?
I think yes.
It doesn't get easier on the show every day, just so you know. If you're thinking today's gonna be easier than yesterday, I'll keep challenging you. I'll keep like, wait, write that one.
But wait, we're not in the right place.
Find out where to go first. There you go. Good job. You're in the right spot. That's like the biggest deal in programming is finding your way to the right spot.
Okay, so okay.
Good. Pretty close. I don't know if I would do that. Well, I'm sorry. You don't have to shut up. You just do it. You do it and we'll take a look at it. This can work. This can totally work.
Yeah, okay. and
Yeah, that was a bad dad. Those are bad dad words. It's not equal to 0. That can work.
because if it's negative, well, we wouldn't want to show it, but we have other code for it. Oh, wait. We have other code for this, don't we?
Okay.
Wait. Where is it? Organized members? Is that the one? Nope. I don't think so.
Undo. There's a refactoring available on the if statement if you're looking for refactoring.
Yes. What is
Here
it?
on the if statement and hit the on the if statement.
Oh. Oops.
There you go.
Oops.
Split conditional might be what you're looking for.
That is the one I was looking at.
Yeah. That's kind of what I was.
And
kind
then
of
wait.
If we're a
Yes.
fraction, then we're going to go in this space and now we're going to start.
And then else. And then
By the
here,
way, okay, go ahead. One second.
I like to put verses
That's totally fine.
just in an
I
else
like it too,
statement,
especially
especially.
as you're starting them up, as you're creating.
Yeah,
Okay.
okay.
Just let me know
And
if you
then
might
here, return. And this one is just the whole number.
Yep.
Whole number. What? Oh, right, that's on the inside of the method.
On the inside of that string. All right, are we done?
Yeah.
Then we test it. Save and test.
Yeah. Okay, and now we want to test if it's if it would be equal to. Oh wait, no, that works. Yay.
Wait,
Oops.
let me push it. So I'm going to change this to a fourth. Looks good. I'm going to change this to subtract. And now I'm going to, I don't know if that's right or not, but now I'm going to change this to 1/2. Uh-oh.
Okay.
Are we not simplifying?
Why is it like that?
I don't think we're simplifying. The answer is technically correct. Right? 1/2 minus 2/2. Let's make 1/2 minus 3/4. All right. Let's start with this one. What do we think about this?
Well, I think one thing we might want to do as well is to if the whole number is 0, just don't show it.
Good.
Which
Right
is
there.
easy.
Give me some code that does that, please. See, the secret plan in doing this show, Campbell, is really just turn you into my personal coding assistant.
Yes. Yes. And
The
really,
whole point.
you've been my coding assistant the entire time. Okay, so this is phone number is equal to 0. Then we want to return.
You drop a marker here, go down, copy pieces if you want to copy something, come back up. Or you can just type it in.
Okay, I might do that. I think I'm just gonna go do this for right
That's
now.
You got IntelliSense, it'll help you out.
Numerator over denominator.
It's not giving you IntelliSense because
Oops.
the numerator isn't close.
Oh, I must have.
More space. Try moving left and then control space again.
Why isn't it?
Control space. Just do control. Okay, or do that. Yeah.
Okay.
If control space ever doesn't work, just move the caret left and hit it one more time. Alright. What's interesting is, it says it's false. When you typed in just the first number, oh no, wait, get a space. 1. Oh no, it is good. Okay, cool. Wait, go back. The answer's wrong. Type in a 1. That should be 2.5. That should be a 2.5, my friend. When we get to here, it's right.
Why is it not working?
All right, we need a new test case. Stop everything. When we find a bug, stop everything. Let's go into fraction tests. We need test 3 nums. Right? Doesn't matter. We don't have to really figure it out. Test 3 nums. The first thing we do, 3 nums, 1. So test 3 nums. We're going to hit AT for assert is true. Put in that string right in there. Like that.
Dot eval.
Equals, we're looking for 2 and 1/2, right?
Yes.
Okay, dot eval. All right, let's confirm that this fails. Run it.
So we want it to fail. Whoa! Oh, come on. Then I think
What?
it's either what we're showing in XAML.
Well, I'm glad that
Or-
passed. So the problem is, I am calling 2num on it. Let's go look at 2num. Set a breakpoint here. Run it with that same text again. I think I take, what did I do? Yeah, 1.5 plus 1. So let's step inside here and take a look at this. So left, right. Are we going to be able to find the left, right? We should be able to. Let's see. Yep. Operators plus. Left, right. Well, that all looks good. And we added them together, and we got the right answer.
What? Yep, it's definitely a problem of what we're showing in XAML. I think.
Oh. We only set the answer if it's a fraction. We don't set the answer if it's a decimal. In fact, all we need to do is call set answer, because this code, we don't need that anymore. We're just failing to call the code. It's just showing us the last thing that was there. Okay? All right, there we go. Cool?
Cool.
Now, one other thing.
Good. And that is to test the code we just wrote.
Well, I really want this to be equal to 2 and 1/2. So let me do one more thing. I'm going to create another test. We tested. We run all the tests. I'm pretty sure. I heard you say you test the code. We can do that.
No. Not there. I was talking about the code that we just wrote. For if it's 0, don't show it.
I gotcha. Okay, right. Let's do that.
I mean,
we create a quick test method. It's going to be called test display stir. And what I want to do here is AE for insert equals. And my expected value is going to be 2 and 1/2. And the actual value is going to be, let's get this into a string.
2.5, I believe.
That got 2num.
That.
Right there. Because what's currently happening is this should fail. And let's run the test real quickly so watch it fail. Okay, expected 2.5, but was 2.5. Okay, they're the same, but I want display string
To know that they're the same.
to not convert it to a decimal. Why did you convert it to a decimal?
I think it's for our code that we put in there for this. I think it's in display string that we use it.
It's not in display string.
Or
It's not. The reason, look, this is coming in here with but expected 2.5, but was SN 2.5. Was is coming from our toString, which just calls display string. Display string says, hey, if it's a fraction, let's do this. But if it's not a fraction, so go back and look at the text. I'm adding this. Is that going to be determined as a fraction?
Yes, but the second
To this, is that
number
going to be
is
determined as a fraction or a decimal?
a decimal.
And if we add a decimal to a fraction, what do?
We set it as a decimal.
We set the whole thing as a decimal. So in our operator overload for plus, we need to go take a look at that and change things up in there. There it is right there. So op plus. So here's where we check to see if either one's a decimal.
Yes. And if either of them are a decimal, then we just return the value as, we return the SuperNumber as, okay.
Is that fair to say cannot be fraction? Is not a fraction? Is not fractionable? Let's do that. Let's declare that as a property right there. And
But everything is fractionable.
yeah, is not simply fractionable, maybe a better name. And we're going to say, what's that going to do? That's going to do, put a getter right there, and we want to basically say, hey, look, if type is equal to decimal, then I guess I want to check to see if it's a whole number, but really, look, I want to say, look, if is whole number, then I'm going to say, I want to change this to is fractionable. I think it's better to not have the negative in here. Lose internet? What's happening here?
Oh no. Yep, connection lost. There was a problem with the network.
OBS shows that it's still going out though.
I appear to be still connected.
I lost my,
OBS is still working. Yeah. Okay, I think we're back. Skype.
I just got to get the mouse without borders to get me back over there.
Oh.
So it's connected now. There we
Yeah.
go. Okay. So we're going to rename this to is fractionable. So it's a little easier to remove knots from things. So look, if it's a whole number, then we should return true. We'll say, hey, if type is equal to number type dot fraction, what am I going to return here?
Then we want to return as false, right? Or
Fractional means I can represent it as a fraction.
oh. Well then
Type's a
true.
fraction, I
Wait.
can represent it as a fraction.
Well then the whole number is also true. But if it's, you know, a
Yeah. If his whole number is true, I can also represent it as a fraction.
So now we just need to specify what is whole number means.
Yeah, or maybe, let's not do that, actually. Let's not do it here. Let's undo this again. Let's back up, let's back up, let's back up, let's back up. Let's undo everything, let's back it up. Don't be afraid to do this. Okay. Back it up all the way. We'll leave the code all the way as it was. Here. Basically that. We're doing that. Let's go see when we set this to decimal type. Here. See this? In initialized decimal?
Yeah.
This is called when we have a value all by itself. So we call the decimal fractionator, that's the regex thing that finds different parts. It says, hey, if the decimal value is not 0, then we're going to initialize it decimal. Otherwise,
Yes.
we're going to treat it like this.
And yeah.
So what I kind of want to do here, though, is I want to say, hey, if it's a whole number, it is whole number on value. Then I want to call initialize fraction, passing in value and 0 and 0. And exiting the method so I never ever get down to this other code down here. So how do I exit the method?
Yes. Return.
There you go. Now this is, value is a decimal, but we know it's a whole number because we haven't written this yet, but we're going to write that. Argument 1, cannot convert from decimal to int. What do I do? Can you fix that for me?
Yes. CI.
Hold on though, I just realized my connection to you. Oh, we need to restart this guy. There we go, now I can see. Okay, good. And then we just have to implement this whole number. And if we do this, that test case that failed, this one might start working. Okay?
Yes.
So to tell if something's a whole number or not, we basically need to say, hey look, bring a variable called decimal part, and set that equal to value minus math.round, math.floor. Do you know floor and ceiling?
Yes.
Tell me about that.
Math.floor rounds down, math.ceiling rounds up.
So if I say the value minus the floor,
It will just get the remaining decimal, if there is it. Or, you know, the point blah 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 is what it will get.
floor is not quite what I want, because guess what? Floor on negative numbers makes it get bigger, and I want to get it closer to 0. So what I need to do is say
if type dot, or if the type is negative, which we can do.
then multiply it and change it. Yeah, I can totally do that. That is absolutely the correct way to do this. I'm going to do this.
But
right
that's
here.
another way. Yes.
I'm going to do absolute value,
value.
and then I'm going to use it here. And now this is my decimal part. So now, how do I know if it's a whole number or not based on the answer to this equation above?
Well, if decimal part is equal to has value.
Okay, so if decimal part is not equal to 0,
Yeah.
then what do we return?
Then we return whole number. Is whole number, or we return true.
Return true. So it's a whole number if there's like a 0.5 or something added at the end.
Oh wait. No.
Okay.
Then return false.
There you go.
Oops.
All right, and then otherwise, what do we do down here?
Otherwise, we return true.
Right. And we can take both of these, by the way, and flatten the conditional. Counter says it's refactoring. They'll say, hey, return decimal part is equal to 0. Does that make sense?
Yeah.
You like it better this way?
Yeah, that's I think a bit easier to read. It's
What if we changed this to equals, made that true, and the other one false?
yeah, that works. That's another
Decimal part
way.
is 0, return true, otherwise return false. Okay? So that's, if it is a whole number, then we're going to initialize as a fraction. Now that we've done that, let's come in here and rerun this test case. See if that one passes.
It probably will. Oh.
Ah, look. Expected
Oh,
to
but the
string,
SN.
but was
Yeah. A super number.
Hold on though. I want to double check that. To num, I have to call over here to display string. I have to put display string in there. Now the test will pass.
Okay.
Because you see what's happening? It's
Yes.
comparing SN, a super number, against a string. We could also add implicit conversion to a string to say, hey, if you want to convert to a string, I'll just call display string.
We could.
Why not? Let's add that actually. So I'm going to keep this here to where it fails. So it's going to fail. I'm moving it back to where it fails again. Okay? There, it fails. Now let's go add implicit conversion. We've already got an example of it. Here we go. Let's duplicate this. This time we're going to convert to a string, and we're going to return d.displayString. That's it. All we have to do. Okay? Let's go back in and run the test case again. This time it should pass. Implicit conversion to string exists. Sweet.
Oh, I just realized something. With our code where we took its absolute value and then we said, and then subtracted its math.floor from it, and then if the remaining was not equal to 0, we could just make that if remaining is greater than 0. Because we're taking the absolute value.
You're right, you totally could.
We don't need to, but...
So this would be the same as if decimal part...
is greater.
Well, this one is... We just have a double check. We have a check on this decimal part 0. But the code we had before, we kind of do that.
Yeah.
Yeah, you're right, you're good. Good observation. Okay, let's go back to our application. Let's run it. See how it looks. We need to test that at 0, I think, right? You wrote some code. Do you remember what that is?
I do. So...
Black Tower says music's found a bit loud.
Oops.
How's that, Clock Tower? Sorry about not seeing that. So that's better.
1 1/2. Oops, 1/2 minus 2 over 1. And that's, it works. Before it would show a 0 and 1/2.
Right.
But
So
now
that is good. What if we have minus 1/2? What happens when you type 3 minus 1/2? What's it do?
1/2?
1/2 minus 1/2.
1/2. It should work. It should. We
Go
didn't
fix
write
it.
code for this.
Go fix it.
So we want if it's if the denominator is equal to 1. Where is it? It's not here. It's definitely not here. It's here.
What's happening? Do we need to call simplify on it?
I think probably, but I think for right now we can just do an easy solve.
What's simple? Well, go ahead. You tell me what you want to do. You tell me what you want to do.
I think I'm just gonna create an if statement for now. Denominator is equal to 0. Then we will return. Nope, that is not what I wanted.
Undo. Just an undo. Undo. Just R for
R. Yeah. Return interpolated string. Boom boom.
Can you tell me what you're thinking about
We
doing
just
here?
want oh, wait a minute.
Why are you checking denominator 0? Because divide.
Oh wait, sorry. If denominator is 1. And we also want to check if the whole number is right. If denominator is 1, return whole number. Whole number. Oops. Wait. Oh yeah. I think this should work, right? Plus numerator. Oh, I'm not sure. We can test it though. One and 1/2. Minus 1/2. It's just 1. Yeah, it works. But what if it were to be
Can I jump in with some ideas?
There's one more thing we need to test. I'm not quite sure how I want to write it though.
So I'm a little, so it looks like it works. Just a little worried about that.
It's temporary, I think, because the simplify method, I don't think, or I think the simplify method would take a bit too much time.
I want to do this. I want to create a method called clone. Oh, cool. Do we already have a clone in here?
We do.
That's awesome. Look at that. We don't need these this keywords. It's some people find that code's easier to read with them. We don't need to because they reference this class.
Yeah.
This class. Find code easier to read without them. So cool. Clone already exists. So we're going to come in and say SuperNumber dot clone. Then we're going to say SuperNumber dot simplify. What? We have simplify.
Oh, we don't.
I really thought we had simplify.
So did I.
Hold on, let me drop a marker here. Let's search the whole simplify. Maybe there's a comment out there somewhere. Find simplify. It's a lot of stuff to search. Let's just look only for start.cs files. Yeah. Yeah, it looks like it's absolutely not funny. Okay, so simplify doesn't exist, so we're going to have to make it work, simplify, or maybe we'll just say simplify creates a new SuperNumber. Like that. And then we're going to say, and it creates a SuperNumber that is simplified.
Yes.
Because I'm just worried about if we change what we see, but we don't change the internal representation, then it's more likely to create a bug. Does that make sense? Because we're only solving this problem when this problem starts approaching the eyes of the viewer. That's kind of what I'm looking at there. A little bit worried about that. I guess we're going to implement simplify. I thought we already had this.
I think you were thinking about our multiples, like find the least common multiples. I believe.
Let's go look for that.
We had it in another in another project. I think.
Sorry, Solution Explorer. SuperCalc Core. SuperMath. Get common. What are you using that? Make fraction proper. Notice here, if numerator is greater than denominator, this should be greater than or equal to.
Ooh.
I contend that should be there. Make fraction proper. Does it in fact simplify? It does. This simplifies.
Yes, it does.
This is our simplify method, I think.
Yes. Yes.
Yeah, make fraction proper. I'm going to do this. Simplifies the fraction. I'm going to put the word simplify in here, and it simplifies the fraction. So in case I ever have to search for it again, I'll find it.
Yeah.
Okay. So we clone it, and then make fraction proper changes ourself. maybe instead of calling simplify up there, maybe should I do it? Let's say return the clone dot make. Remember, we need to call make. Hold on. I need to get a new SuperNumber here for clone. We're going to call make fraction proper before we return it. And then we got to return the clone. Okay. So that simplify will create a new one and returns a new SuperNumber. As a simple fraction. Okay?
Okay.
So we've got simplify now. Now with SuperNumber, I want to say we got to kind of throw SuperNumber in front of all of these pieces.
Yeah.
Maybe we'll do this. Maybe it'll be better to do this. Just say return SuperNumber dot get display string. Which will be we'll make it a private method, and it'll do all this work here.
Yeah.
So get fraction display string. So we'll do that, declare it, put it there. So what's interesting about this is that the question of getting display string, if it's a fraction, it creates a new instance of a SuperNumber. Then it simplifies it. Simplified clones this one, not changing the current one. The value of that is that if I have 2/4 and I want to still keep it as 2/4, I can.
Yeah.
So maybe I want to add it to 3/4 or something like that. But I can still get a good display on it. So what I do is I call simplify, then I return the get fraction display string on it. And so now we've got this, and now I don't think we need this anymore. That's my hope. Let's run it, see if we can duplicate it. What was the test, do you remember? Getting that to work?
I think I do. Yeah. It was.
It was one half plus 1/2? Is that right?
I think so. It was something like that.
That gives us 2 halves, which would give us just a 1. All right, let's run all our test cases.
Wait, I want to try something.
Go ahead.
Okay.
Nice. Do something that adds up to 6/8 and see if it gives us 3/4.
Okay.
All the test cases are passing. There are 27 test cases.
Woo.
That's awesome.
Okay.
So what, 3/4 plus 3/4?
Yeah. 3/4 plus 3/4.
Yeah, that would give us 6/8. So somehow we're getting there. But minus 1/8. Oh, we can't do that. We can only do 2 numbers together. We don't have anything that allows us to string these together yet. What do you think?
Huh.
Was there somewhere else you wanted to go?
No, I don't think so. I don't think so. Maybe. Not that I can.
Can we bring the Khan Academy question up that says, one fraction divided by another fraction? And see if it works. Can we throw this at Khan Academy?
Okay, so that would probably be in arithmetic operations. So dividing fractions.
Yeah. Those are the things that are always, for me, that are a little bit like, what? I got to wrap my, got to gear up my head. I got to get it engaged.
Dividing fractions. So 4/7 divided by 7/2.
All right, here we go, kids. Move it so that we can see both at the same time. Move it the other way. Move it so that the numbers just, yeah, there you go. Perfect. All right.
So 4 over 7 over 7 over 2. 2.
Just an extra space.
Oops.
And the regular expression doesn't allow that.
Okay.
Got a breakpoint. Looks like 849 space. Coming back. Alright, enter it and see if that works.
8 over 49.
Nice work.
Okay.
We could also create these, by the way, look at this. We could create test cases.
We totally could. So 8 thirds.
We'll try it.
And
You'd add a copy button too, so you just come over and paste the answer.
we could.
You want to do it?
Sure.
Let's do it. Let's add a copy button.
Okay.
Alright. Everyone that goes, they say you're right here, we should add as a test case. So let's do two things. Let's add a copy button and add a generate test case button. We're gonna add two different buttons. Alright. So
Copy button's easy.
just B for button and space. You might want to get the tab out to get where you want it to be. There's no worries, you can put it here too.
And then you can
BTN,
control K.
BTN copy,
D.
answer.
Huh?
BTN, call it BTN, copy answer. BTN, tells us it's a button, copy, answer. Okay, and then put the text copy answer inside the button.
Copy. Answer.
Good. Double click that button to generate it. You have to, once you've gotten the text activated, you have to, yeah, click away and double click it. Click but not on the text. Stop the left. There you go. Good. All right. So here's what we want to do. We want to say clipboard.setText, I think. Type in clipboard dot L, so you can get it. You tell us what's help you out. Down one arrow.
Dot set text.
I think that's what it is. Type set text. See the one at the bottom?
Yeah.
Set text, open paren.
And then here we want the answer. So do we have a string?
There's a control. There's a control on the form called LBL something. LBL answer. I think. Start typing in LBL. This is why we look. This is why we prefix things on the form, so we can know. Oh, it's a label. I'll just type in LBL, and IntelliSense will finish it. Answer's got a property called content.
Dot
LBL
content.
Answer, dot content.
Which is a string.
It's not a string, unfortunately. So we're going to say as TS, and that should work.
Why TS?
We said it. What'd you say?
Why TS?
Oh, TS means type reference, and then I just followed the shortcut. S for string, D for Boolean, right? I for integer, that sort of thing. DE for decimal. It's just a quick way to get the class out. Okay. So we'll set the text. That's one. The next thing we want to do is we want to create another button. Go ahead and add another button there called create test.
Oh, we need to move this one down. No worries. So BTN create test case.
Yeah, create test case.
Okay.
So what we're going to do is we're going to, if Khan Academy says it's correct, what we say is correct and they're incorrect, we're going to create a new test case for it. Then we're going to paste that in.
Margin. M4, is that the template?
M4, you can try that.
Oh wait, no, that's
You
not
need to
what
put
I
some text
wanted to
in
do.
there first though. It thinks it's got zero height because there's no text.
What is,
Put text
oh,
right there, we're importing it.
okay. But what is the
M0.
template for this?
M0.
Oh, okay.
I think it is.
So text here is create. Oh,
Yes.
never mind. That doesn't work actually. Test case.
All right, cool.
Oh. Period. And I will do M0. Which one's height again? It's the second one. This one.
This is from the top.
Yeah. So, what is the current distance from the top, do you think?
Make it 20.
Yeah, I like that.
Okay.
I think that's fine.
We can also do this. There's a max width setting. I think it's MXW. And I can follow that with a number like maybe 200. It's just MW, isn't it? I have always got problems remembering these. MX. Oh, you know what? They're not on your. These are not on yours. So let's say 200. 280. We're going to say 340. 370. Right, there we go. There's that max width. We'll do the same for the button above, just so it doesn't look like it's taking up so much space. All right, double click on create test case, and let's have code for that.
That's not what I wanted to do.
Okay. So here we have a situation where we have our TBX equation text. So let's just work with the variable here first. It's going to be our test code. This. Okay. That's going to be equal to, we're going to start this with assert dot is true. Are
Yes.
equal. We're going to do that. That's the first part of it. Right, because we look at our tests. Where are they? We start with this. Right?
Yeah.
In fact, what we could do is actually grab the whole thing and just do it as an interpolated string. So we want to make sure these two are equal. So we're going to say, change this to an interpolated string. And we need a string here at the beginning, so we're going to escape this, escape that, like that. We need to now, we don't need any of that. We're going to pass in, at the beginning, we're going to pass in TBX, which this needs to be in braces. So TBX equation.text. So the text of the equation goes as the first. Oh, no, that's not the first parameter. The first parameter is the answer. So let's put that one in. And that's going to be in string too. Are you following this, Campbell?
A little bit. Can you say that again now? What you just said?
I'm going to put the content of the answer in first. So the answer's content in first. That's what we're expecting. Then we're going to put in this string, but we're going to call toNum on it. Like this.
Okay.
I'm trying to generate
Cool.
one of these lines of code.
Yeah.
Right here. Once I have that in my test code, then I'm going to come in and I'm going to say clipboard.setText on it. So copy that to the clipboard. That makes sense? And then we'll try pasting it and see if it works as a test case. So let's create a new method in here.
Is there a way to just directly put it into the code?
There is. But it
Through the
requires
code,
way more work than what we're doing right now. So we'll keep it simple for now. That's like 2 or 3 shows, and then we can do it. But the answer is yes. You have to create an extension or a plugin inside of Visual Studio, and you have to have your application talk to the plugin. Does that make sense?
Yes.
But yes, we could do it. But for now, we're just going to do this. I'll drop a marker right here, so in case we leave this place, we can hit escape to come back. This is where we're going to put our auto-generated tests. And with that, I think we can run. We run. All right, let's go back to Khan Academy. We're going to try to test out copy answer, see if it works. And we're going to do
Okay. So 3 over 5 over 1, 9.
Copy answer. Paste.
Copy.
Check. Good. It worked.
Okay.
Wait. Now don't do anything.
Oops.
Now go back to where we were and choose create test case. Now go back to Visual Studio and paste it. Right in there.
Here.
Paste.
It worked.
I think that worked.
It
You want
definitely
to stop
worked.
the program and test it, or do you want to get a few more?
Let's do a few more.
Okay. So let's do a few more. Next question. Isn't this awesome? We have one of the few fractional calculators ever created in the world. I don't think there are a lot of these.
9. Yeah, that's probably true.
Well,
I'm assuming there are a couple for sure, but 25/72.
Nice work.
And then create
Create
a test
test
case. I think there should be some feedback for this.
Where it says it's on the clipboard?
Yeah, or something like that.
Okay, well, we're running right now. Here, go ahead. Hit enter. Paste. Sweet. Let's save it. Go back. Wait. Go back to our app. Let's set a breakpoint. Oops. I want to set a breakpoint. Set a breakpoint for me. And then we'll change the code so it puts up a message box.
Here? Or
Sure.
on line 76? Anywhere would work.
It can be anywhere in that method, because we're going to put it at the end of the method. All right, let's do another one. Isn't this awesome?
Yes. Oh,
Wait, did you do it yet?
oops, that's not where I meant to put it. Okay. I
So
need to put my cursor up
1/9
here.
cents.
1/9 divided by 8 seconds. 772. 772.
Check. Good. Give me a test case.
Create test case.
Okay. Now, what we can do is if you go down after line 77, hit enter after that. Let it go get to that empty line. You hit end. Go down and then end. 2 keys can get you to that space. End key now. There you go. Good job. Enter.
Enter.
And now you're going to say MBOX.
MBOX. Oops. O.
B is in box. M box. There you go. See that? Right up there? That's
Yeah.
the code snippet. If you hit the tab key twice now, it should expand it. And, okay, not bad, but oh, we're not using this in those forms.
Control dot or insert key.
Yeah, we're not going to be able to do this. We're not going to be able to use this. It's like, okay, you can't do that. Oh, but there's a message box in the win form. Cool. So we'll say, copy clipboard. You want to write this in? You want to do
Yep.
something? Go ahead.
To the clipboard.
And let me show you one other thing.
And then
There
we
should
need
be 2
to.
parameters to show. There's one, but there's also a second one where we can pass the caption in. What if for the first one we just put the test code here so we see it? So let's hit run, and I'll show you what I mean by that.
I think I know. In our other code for the regex explorer,
We put
We
the
had
word
it.
good luck in there.
yeah, I think, or something like that. Yeah.
Nice. Sweet. And now we can go paste that in. That's in, yeah, there you go.
Fraction tests.
I think there's the marker's still there. It's up above the top of the screen. Hit escape to get to it. There you go. These are great tests.
Okay. Up. Over 2. Over 8 over 3. Copy answer. Control B. Check. It works. And then create test case. Oh, I love it. I really like it.
Yeah, it's cool. Yeah, it's nice feedback. So these all better pass, right?
Oh, yeah.
If these don't pass, we get some trouble. But this is one of the cool strategies, right? We're actually writing code to write code for us, so we don't have to write code.
Yeah, that's what we did with the regex.
Right, right. So we're able to do bigger things with less work.
So 4/3 over 7/8.
Do you ever think, oh man, this would have been really handy to have when I had to do these problems?
Yeah, it would have. Because when I was doing these, it was so tenacious.
Tedious?
Or sorry, tedious.
You were
not
tenacious because you didn't give up.
Yes, but it was very tedious and repetitive. Okay, and now...
Wait, go create a test case for the last one we just did.
Oh, right. Create test case.
Nice.
Enter Control V. Now, hopefully these all pass.
You got to
close
the app. The app's running right now? Yeah. And then run all our test cases.
Yeah, just because we can. Woo!
28.
They all worked.
It's awesome. It's really, really awesome.
Okay.
Once you're checking the code.
Alright. So, well, we,
I always like to click on the files to remind myself of what happened.
we changed the user interface a lot. So, we
We changed the UI, made it simpler. This is kind of interesting because normally I start designs with the UI, but in this one we kind of did a little bit and then we just kind of walked away and we really focused on the test cases and the core, getting that really functional. And then we started working on improving our test cases so we could write more tests more easily.
Yes, and then what we did is we, well, I guess I'm not sure how to say it.
Give me a clue. What you think about?
The thing we did, I guess we created a code generator.
Sure. We created a test case generator.
Oh yeah, a test created.
So that we could save results to make sure, so if we make any changes in the future, we got to make sure that those equations still are true. It's still got to work in Khan Academy, right?
Yeah.
Test case generator. We added copy to clipboard button. Copy answer to clipboard. Right. Yeah, I think this is it's pretty good so far. Right? This is like something like, you know, I know that you can search online for like fractional calculators, I think, but it's really, I think, really good.
And, well, we added more test cases.
Yep, added more test cases. And we also improved we created, we created an implicit conversion to string, and we made sure that was going to be a simplified fraction if we ever converted to string.
Implicit? Oh wait. So an implicit converter.
Implicit conversion. And that we did it with only a single line of code. Conversion to string.
To
string
And simplified, I guess.
Yeah,
Added
that
a
shows
simplifier.
simplified fractions.
Yeah.
Basically, simplifies fractions. Yeah, it simplifies fractions. Okay, cool. Are we really moving towards units now?
I think we are.
Yeah, we also in the show can see units. We've done
But why? We still have so much more time.
Okay. Let's stage those.
Stage all. Commit.
Commit.
Push changes immediately to origin.main/main.
Give me a copy of that URL again. I'm just going to machine copy it. The GitHub KidzCode. There it is right there, SuperCalc. We've got our SuperNumber, there's our calculator. Throw that out in the chat room again, everybody watching this. Okay, units.
Okay. So probably, I'm assuming meters is the unit we want in. Or, oh right.
I kind of want to support any unit at all.
Yes, but I think we should have some default units as well. Like some units that you can just press a button and have it put in. Or
I don't want to type them in.
okay, and then whatever the unit, we just have the answer. Wait a minute.
I
That
want
actually seems like only a couple lines of code.
I want to figure out. I want to be able to type them in.
Yeah,
That's what I want to be able to do.
it's just a couple lines of code then, I believe.
Yeah, it'd never be that optimistic, please, around me. Never say it's only a couple lines of code.
It sounds like it
Don't
is.
you ever be that optimistic.
Well, we already have code to find out what parts of the string are what, and we already have the Reg Explorer to help us with that if we need it.
Well, we need a
And-
new regex string, but you realize I prep you for danger, right? For disaster at every moment. The
Yes, but
tigers
we
could
could
come
make
flying
it-
in through the window.
Yes, but we could make that danger not less dangerous, but more efficient.
Let's talk about it a bit before we decide how many lines of code. This is over my machine.
My immediate thought is, though, like my first guess is approximately like maybe 5 lines of code.
Really? Okay.
That's what I think.
I'm thinking no way. I'm thinking 20, and we're gonna have to put our brains at it. So let's talk about this for a second.
I
Let's
don't like putting my brain
put
on
the
it.
number 1 right here, and let's put a unit next to it. Meter. Okay?
All we have to do is find that unit.
And if we need to multiply that by, let's say, 2 meters,
Wait a minute. Sorry, pause for 1 second. We already have this code in our Khan Academy question solver meter thing. You know, thing.
that's a little bit different. That was a dedicated solver that was for convergence. Okay?
No, but we have code so similar to this that I think it would just be copy, paste, and then tweak, 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 tweak,
Okay,
tweak.
your optimism is in direct conflict with every sensibility I have. And as a result, my head is screaming. So let's just be calm, shall we? All right, so here we go. 1 meter times 2 meters. What's the answer to that, Camel?
1 meter is 2 meters.
What is it?
2 square meters. 2 meters squared.
2 meters squared. Okay.
The meters are squared. Oh, but we, oh,
1x.
but I see.
So let's unmute that x. Let's make this 1y. Let me talk about variables for a second. 1y times 2y. What's that equal to?
2y squared.
2y squared. So a unit behaves.
Yes, but sorry.
Like a variable.
If you're thinking that we're gonna have to create something for all exponents, we already don't have code for more than two fractions or 2 whole numbers or 2 decimals put together. So we can't go past 2y squared. We can't go to 2y cubed, or unless I guess we have, yeah, true, you're right.
Yeah, but I can certainly do this. I could say what's
Exactly,
1
I know,
meter
I know.
squared
I know,
times
that's what I was thinking
2
when I
meters
said,
squared.
oh yeah, you're right.
And the answer to that is
That's it.
4 meters squared. And what is
Okay, still,
what is what is x squared times 2x? Oops, sorry, I said 4, that's wrong. This is 2 meters squared. Just cross over that, and that's a rule. 2 meters squared. And what's x squared times 2x squared? Oops, sorry, this is the 4th.
Yeah, okay. I was confused for a second because I was like, no, that is to the 4th, but maybe no.
So this answer is 2x to the 4th. My point here, Campbell, is that the unit behaves like a variable.
It could be to any exponent.
Which means if we're going to add a unit, we might as well just add variables at the same time.
Yeah, we might as well, but if we want our code to be efficient, you know, and we could for variable math problems and things like that, but I don't think we have to.
Are you okay, man? All right. So that's one of the things. Now notice that when we have one unit times another unit, the power of that unit goes up. We basically add up
those two exponents on both of the units.
Exactly. Same thing here. 2 plus 2 is equal to 4, right? So we're going to take that, and we're going to add them up to get the 4. Same thing here. 2 and 2. We add those up, and we get to the 4 right there. 2 times x to the 4th. Okay? So what that means, from my perspective on this, let's just go here and talk about this. Here's what we've learned. Units and variables are so similar, we should think about, or consider is maybe a better word here, we should consider adding both at the same time.
That's probably true.
Well, we should consider it. Consider doesn't mean we have to add them. We should talk about it. Right? If I say we should consider it, it's almost always true. All right, we've also learned that units. Well, let's talk about this, actually. Let's look at this really. Let's look at another page here. Let's create a new page. Sometimes you might see a sign that says like 40, right? Also known as kph, for kilometers per hour. You seen a sign like this ever, Campbell? Mm-hmm. Sometimes in the States you'll see something like this.
MPS, or MPH.
All right?
Miles per hour.
Right, something like that.
There's also meters per second.
Sure. Okay. What's the difference between that unit and this unit?
One's distance and one's time.
Okay. Well, what's the difference, considering ignoring what their types are? What's the difference between a unit here and a unit here?
One's on top and one's on bottom.
And what does it mean if it's on top?
If it's on top, it's getting smaller if we are doing regular division, but in this case,
just tell me what the operator is. What operator do I use if it's on top?
What do you mean?
Well, if this is 40 plus k, is it 40 minus k? Is it 40 divided by k? Is it 40 times k?
It's 40 times k.
Okay, so the multiplier operator is on the top here. And what's this operator down here?
It's division, right?
Yeah, it's essentially division. So
because it's 40k per hour.
Yeah, divided by hours, right? It's 40 times k divided by hours.
Yes.
So we've now learned that essentially both units, and this is true for both units and variables, can be multiplied
and also divided
by or divided by. I'm going to just create these to mean it's something big. Okay? So they can be multiplied or divided by. Multiplied, is that on top or bottom?
Multiplied is on top. Divided by is on the bottom.
Yeah, which essentially means, they behave similar to a fraction. But I can have these on a decimal. Okay?
Yeah. Yes.
I want to change this to divide by.
Oh, I guess.
Change this to multiply by.
So it's like a fraction of units for a decimal, which is really just a fraction. So wait, can you go back to 40 kilometers per hour?
Yep.
Technically, on the bottom it's also multiplication, but not really, because it's 40 over 1 times kilometers over hour. So it's 40 times k over 1 times h.
Right.
But really, it's division.
Right. So we could look at it this way, or we could say, we could look at it this way. So now we've got, see what's going on?
Yes.
Normal or inverted. Or there's another way of looking at it, and actually I think I'm favoring this way. Hold on. All have powers. And we're done.
Yeah, they're all right. I think we should keep them all written down, but...
Yeah, this one's the simplest though.
Yes, we should use that one.
Because look, if I say that they all have powers, what this really is saying is that's 40 k to the 1 times h to the negative 1.
Yes,
and now I have a beautiful world that I live in. Because now, what'd you say?
If we're going by that, and I know this is a logical fallacy, but technically it's also 40 times 1 times 1 times 1 times 1 times 1 times 1.
No, I know, but watch
over
this.
1.
No, but let me show you the value of this. No, follow with me, because there's actually a really strong value in here.
Yeah,
if I have a question that says you're going 40 kilometers per hour for 3 hours, right? So I say for 3 hours, right? 40 kph for 3 hours. That's the same as that times 3 hours, which is here is the same as this times 3 hours to the 1.
Yeah.
Because I have units that are the same, I can combine their powers, which means the answer is going to be 40 times 3, so 3 times 40, right? Times k to the 1 times h to what power?
Just h to no power.
0.
To the 0.
And anything to the 0 power is what?
Is 1.
Which means I can cross it out.
Yes.
By saying units all have a power, we're good to go. We can now implement it in only 5 lines of code. Maybe times 5.
Like I said, whenever we do something where it's like we're manipulating numbers in a way that they're not meant to be manipulated, but it doesn't affect it, it feels so cheaty. Even though I know it's like it's not at all. It's still following the rules of math, but bending them a little bit.
Can you tell me a little bit about that? What feels cheating?
The fact that we're adding powers to these, even though they technically don't have them, but it would work.
No, they do have them.
Yes, they
technically do have these powers.
They technically do, but the fact that in any equation where we're given those numbers, if we add the powers to them, it feels like it doesn't affect the number at all, but it definitely feels kind of like.
You know the reason why is because whoever trained you,
you're never
didn't
taught
point
that.
out that
Yeah.
one is always there.
Yeah, it's like when you're learning basic addition or basic subtraction, you're not at the same time learning addition and powers, or sorry, multiplication and powers and division. So you can't really learn about those at the same time. So whenever you learn about those later, it's hard to understand. And it's hard to accept it, I think, a little bit. If you don't learn them simultaneously.
Well, I'm gonna say open your heart to it. So,
yeah, no, it's true.
All right. So if we want to add units, there's basically. So here, let's come back out here. What we've learned. Let me duplicate this. No, you dogs don't get out. No, no. You're gonna cause trouble. I know. Unit and variables are so similar. I say we add them both.
Okay.
It said both. Okay. So we'll call it. Maybe we're gonna create a new class called unit variable. Hold on a second. I'm gonna say no to the guys.
And we're back.
So we got a unit variable. The unit variable is going to have a name, and it's going to have a power.
Yes.
And I think that's all it needs. Now, when we multiply, we need to add the powers up.
Okay.
For any unit variables that have the same name. So if I have, for example, if I have 4x plus times 2x, like that, I'm expecting to get 8x squared.
Yeah.
Which I think I'm going to write like that. So this is going to, if there's only one, then the power is 1, right? There's only 1. I think this is a big deal. Are you starting to get a sense of, oh, this is a bigger deal than I thought, maybe?
No, I think it's still quite simple.
I think we'll be working on this next week as well.
Okay.
That's what I think. But okay, so we need to do add the powers when we multiply.
We've been blabbering on about it for quite long, so I think it will. We might not even start it this week.
Oh yeah, it's always important to get a sense of where we're going.
Oh yeah, no.
When we divide.
I'm glad we've been blabbering on about it.
When we divide. What goes on when we divide?
When we divide, ooh. Now immediately I start thinking, do we subtract the powers? But I don't think powers work that way. Because, don't they? Because they're like multiplication and division, it's just multiplication of, division is just multiplication of fractions, and same with addition and subtraction. Subtraction is just addition of negative numbers. But powers don't have another operator for them.
I'll show you what happens with powers.
So it would wait, we would just do it negatively.
Let's go find our op. Divide.
Because when we do like division of powers, we don't do division of powers. There's not a different operator. It's just a power to the negative of whatever it is.
I'll show you in a second what it is.
Does that make any sense?
Look at this. If it's a fraction, we create reciprocal.
Yes.
If it's not,
Yeah.
we just take one decimal divided by the other. What do we do with units? What do we do with the variables? Yeah, I think you're about to see, oh yeah, this is going to be more than a few lines of code here. Let's go back over to my machine set and let's look at that. Let's look at what happens with division. Yeah, let's just chill on this. We're gonna explore before we dive in. We're gonna get a sense of what's the magnitude of the task. So let's look about division. New slide. What if I have, let's just talk about things we know, like 4x squared divided by, I don't know, x squared. What's that equal to?
Wait, sorry, that would just be equal to 4x squared still, right? I don't know what to do with the powers though.
Well, let's say that a was equal to x squared. That means we could rewrite this as 4a divided by a.
Yes.
What's
So we would just what's it called? Cross out the a's.
Like that.
So is it just 4?
4. Right? If I had 4 boxes divided by a box, it's equal to 4.
Okay.
Does that make sense?
Wait, what? Sorry, can you say that? Oh, yes.
Yes, 4 boxes divided by box, it's 4. If I have 4 boxes divided by 4, it's 1 box.
Because technically, on the bottom, we don't just have x squared, we have 1 times x squared, so we can, or x squared times 1, whichever we want to call it.
What if we had 4 times x squared times x divided by x squared? What's that equal to?
4x.
Equal to 4x. Well, what if I had 4x to the third divided by x squared?
Yeah, we do just subtract the powers, don't we? Because this would
division,
be 4x.
Division, we subtract powers. Well, we actually don't. We add the powers. We still add them. You know why? Because this would be represented, that would be represented as 4x in our world to the third with another one, x times x to the -2. And 3 plus -2 is equal to 1. So it's equal to 4x to the 1 power.
Yeah. Okay.
All right. So that's what we do for division. For addition and subtraction, what happens?
For addition and subtraction. Ooh. Well, for addition, I'm not sure. Do we divide and multiply? I feel like that's not what would happen.
What's 4x plus 1 third equal to?
4x plus 1 third. There's no way to simplify that.
So what's the rule?
Oh wait, no. Yeah.
Well, wait. What if I have 2 birds plus 4x plus 1 bird? What's
3 birds plus 4x.
So what's the rule?
The rule is you combine the ones with the same units, and you don't with the ones that aren't the same units.
All right, so let's talk about some of the rules we've learned. Okay, so for division or multiplication, well, for division, we can invert and multiply. So we're just going to come down here. Our division is going to just invert the units and multiply them. Do you agree with that?
Yes.
Multiplication, we're just talking about multiplication units, right? Multiplication, we're going to add up our powers for units with the same name. Essentially creating only one new unit.
Yeah.
Okay? With that name. So in other words, I can still have multiple units on top and multiple units with positive powers and multiple units with negative powers attached to my SuperNumber.
Yeah.
And I can multiply it by something else and it's going to find and consolidate. So we need code to consolidate. That means we need code to consolidate. Okay, so there's my multiplication rule. There's my division rule. New slide, subtraction. I'm going to see maybe negative and then call add. All right, so we just have one.
Wait, sorry. Can you say that again?
For subtraction?
Yeah.
I just want to make the second number negative, and then just call add. So I'm adding two numbers together.
Okay.
Does that make sense?
It's just addition of negative numbers again.
Yeah, so I just want to have I want to have as few rules as possible. So instead of having a separate rule for division, I'm trying to simplify. That's why out of all of these, when we hit on this one, we're like, oh, this is the best. Because otherwise I need a Boolean or something, or an enum to keep track of it. But now it's just a power. Is it negative or positive, right? And then it's easy, because then we're just adding the numbers up. It's so easy if we do this. This is the winner, right here for me. Let's put the winner in blue and bold. That's my winner. Okay, so now we're down to addition. So we have those two, and then we need addition. So what's the rule with addition?
Addition, it's just call add. Or...
Right, but what did we do? What's the rule? What did we just see? Do you remember?
Oh, yes. We combine the ones with the same units, but not with...
Only combine supernumbers with the same units. Okay? With the same units and the same powers. What do I mean by that?
No, I think I know what you mean by that.
Can I do this? Can I say, how do I combine these two?
I do.
Right? If this is 3x squared plus 2x, is that equal to 5 times something?
Wait. This is just 2x, not x squared.
Right.
The second one, no. You can't add them.
Yeah, I
you
can't
can't
combine.
simplify it.
So they have to have the same units and the same powers in order for me to combine them. But if I add over here, x over here plus that, then what would that be?
Then it would be 3x plus 3x squared.
Yeah.
Because that's what you're trying to do before without the x. It's like trying to add a line to a square.
Yes. You can't add a line to a square.
Or a square to a cube.
Yeah, you can't add a square to a cube. You really can't do that. It's essentially zero. You just can't cross dimensions like that. And that's kind of what we're talking about. So we can only combine supernumbers with the same units and same powers. So we don't need to worry about any special rules in subtraction. We're just going to make it negative and we call add. Right? Same thing with division. Invert the units and then multiply them. By invert the units, what do I mean? The powers. What happens to their powers if I invert the units? Maybe a better way of saying it is I'm going to multiply their powers by a number. What's the number I'm going to multiply by? I'll give you an example up here. If I have 55 kilometers per hour, and I want to say I want to break that. I want to find out how long did it take when I drove for me to drive. If I drive for 10 kilometers, how long did it take? Is the question. So I've driven for 10 kilometers. And so in order to answer that question, I have to take this and divide by my speed. So I take this and divide it by 55 kilometers per hour. which is equal to 10 kilometers divided by, I'll still use a symbol for now, 55, excuse me, times k to what power?
Wait, k to the first.
Thank you. Times h to what power?
Times h to the negative first.
Good. And now we're going to do division. We're going to invert the units and multiply them. So we're going to change this to 10k. Instead of using division, we're going to times, but we have to invert. We have to invert. Well, I'm going to start by inverting the number. We know that. Okay. All right.
Yes.
But now what are we going to do? What are we going to multiply their powers by to get them correct? Can you see that? Do you know what that is? Can you guess?
Wait. Multiplying their powers by...
Yeah, so I want to have k not times 1, but times 1 times some magic number. I'm going to write right here to invert them.
Oh, by the opposite of whatever sign they're currently...
Kind of, yeah. Multiply them by -1. So this k becomes what? K to what power?
Oh yeah, so k to the negative first.
K to the what?
Negative first.
Right. Times h to what power?
To the first.
And now watch what happens. Right?
And then it's h over k.
This is the one right here, right? So I can now take, shoot. Because it's multiplication, I don't need to worry about anything being the same. I can multiply anything by anything. But what do I have to do with the units?
Wait, you would have to invert them. Or invert their powers at least.
So I'm going to multiply the powers by -1. Combine same named unit variables. We combine those and do what with their powers?
Invert them.
Nope, we already
Change
did the
them to the
invert.
other side.
We multiply the powers by -1 in this step. What do we do once they're negative? What do I do with these two powers when I combine them? I've got a k here and a k here. Those are two same named unit variables.
But they don't have the same powers.
Right.
So we can't.
What do I do? No, I totally can. I'm multiplying them by. That's how I cross dimensions with multiplication. Right? In other words, I can take x to the 1 and multiply it by x to the 3rd, and what do I get?
I don't follow. Can you say
Just
that
look.
again?
Okay, no, I'm glad you said that. But do you know this? If I have x to the 1st times x to the 3rd, what do I get?
X to the first times x to the third. You
Wait,
can't
what?
simplify it.
What'd you say?
You can't simplify it.
Oh, I can actually. If I'm multiplying, I totally can. Watch.
Oh, right.
Let's spell it out. It goes to x to the 1st is equal to
Yeah.
x. X to the 3rd is
So it's
equal
just
to
X times X times X times X times X times.
x times x.
So wait,
So
why
what that
can't you
means
do
is-
it with addition?
What's it?
You can add multiplied numbers, can you not?
We add their powers. Let's move this over here. We add their powers together. See it?
Yes, but why can't we do it with addition? We had it above.
Oh, because we were talking about adding different dimensions. Here we're talking about multiplying. Multiplying is the way to cross dimensions. Addition is the way to extend something longer within
Yes,
the
but you
same
could-
dimension you're already in.
You could still do it if you have X times X times X times X plus X times X.
You actually can. It may feel like you can, but I'll show you. Look.
Well, let's substitute X for 4.
Okay, let's do it.
You can do
X-
4 times 4,
Oops,
which is
sorry.
16,
Hold on.
plus 4 times 4 times 4.
X times x plus x. Let's use 2's instead. They're easier. Okay, so you want to throw a 2 in, right?
Sure.
And so your question is, is that equal to 5 times x? Or x to the 5th?
No, but that's not what we're asking, is it?
We're asking about whether we can combine these, and we said we can't because the operator is addition.
Yes,
You
but we
can't combine
could.
this with that because they're in two different dimensions. You even said to me, well, we can't add a line to a square.
Yes, but this isn't a line into a square. This is just an x. It's 3 dots and 2 dots.
It's not. It's not. It's not 3 dots and 2 dots. Well, hold on. Maybe
Or wait, I guess it's 3
maybe
lines and 2
So
dots.
that's like, so, no, it's not. It's not. You're thinking of it like 3x plus 2x. But it's not. It's x times another x. So this is in
I know it's
dimension
not
3
2x.
and that's in dimension 2. We cannot add them together.
But why not? If we have x is 2.
All right, let's do it. This would be 8, and
Yes.
this would be 4. So the answer
and
now
8 plus
is
4 is
12.
12.
Okay? How do we get to 12 by multiplying by x? Right? How do we combine these together that's also equal to 12?
What do you mean?
Well, you keep talking about combining them. Why can't we combine them conceptually? Well, conceptually, the reason why we can is because we cannot combine a line with a square.
We don't need to do it conceptually, we just need to be able to do it.
What?
We don't need to be able to do it conceptually, we just need the code to be able to do it.
I disagree. I think we need to be able to do it, and in order to do it physically, we have to be able to first conceive of it. So we have to come up with a way to combine them.
But we're not doing it physically, we're just doing it
We're not
as,
doing what?
we're just doing it as a problem, not as, I guess.
Wait, are you suggesting that if I fill in a value for it and I get an answer that I've effectively combined them?
No, that's not what
Then
I'm
are we
saying.
not done with your combining? Do we still have more to do? I guess where are you suggesting we go next?
No, I guess that is them combined. Sorry, yeah.
It's not.
That is-
Yeah. So them combined is this. That's kind of what I get. That's the closest I can get. I cannot simplify or combine these anymore
Yes, but
because they're in 2 different dimensions. Do you agree with that or do you disagree with that?
I disagree because
Then how can I combine them more? Show me.
you already have, you just have, is x times x is equal to x times x. Have you not? Or not is equal to, sorry, plus x times x.
Yeah, these two are the same. But, are you saying this one is
Yes,
the
but if you
combined one?
simplify each of them, then you can add them. Because they're the same, I guess.
I think you're suggesting if I know the value for the variable, I can fill it in and get an answer.
That's not what I'm saying. I'm
Okay.
saying you can take x to the x cubed and make it x times x times x.
Okay, which we did here.
And then you can take x squared and make it x times x, and then you can combine them.
And then what?
And then you can combine them.
No, I can't combine them.
Why not?
I can't go from here to, what would it look like?
Wait, it would look like we have on screen, x times x plus x times x.
But that's not combined, that's still spit out and separate. They're 2 separate pieces. They're not combined in any way. I'm having trouble calling this combined.
Oh, no. I'm saying you could simplify it though from there.
To what? You gotta tell me what it is you think it is, and then I'll show you why that won't work. Or I'll show you why I think that won't work. What is that? What's the simplified version of that? I know this is not happy for you right now.
Well, oh, I guess you're right.
Doesn't that suck?
What?
Doesn't it suck when you think something is going to work and then you find out it's not? And you're like, oh. Right, but it felt like it was going to work to you, didn't it?
Yeah.
Yeah. So, to be fair, when I was your age, I felt like this should be able to be solvable as well. And I worked at it for a while, much longer than you did.
And it is if you have the values, but you don't. So you can't simplify.
Right, just like with units, I can't add, meters squared to meters. I cannot come, if I'm adding, I can't do that, but I can multiply, right? I can multiply. The reason I can multiply is because these are already multiplied together, and it just kind of works out, right? If we kind of look at that, right? If we look at like x I think you start to see these kinds of things as you start looking at powers more. Just kind of look at that. That's how we'll spend the last 10 minutes here. So if we say x squared, that's equal to, well, that's just equal to x times x. If we say x to the negative 2, that's equal to 1 all over x squared, which is equal to 1 over x times x, which is equal to 1 over x times 1 over x. Does all that make sense to you?
Yep.
Okay. And if we want to multiply, if we want to say, well, let's do x squared times x to the third, we can simplify that. And one way we can prove it is by spelling these out. Well, we can x squared is x times x, and then x to the third is x times x times x. The very definition of power means how many times I'm multiplying a number by. The reason we add them together is because it's the definition of the power. Definition of power says how many x's are there, let's add them up. So that's equal to x to what power?
To the 5th.
Yeah, it's x to the 5th. That's why we can combine them. We can combine them because the operator here is multiplication. But if I have x to the third plus x squared, I cannot combine them because there's no defined combination for that. Now, that's not to say that you can't invent something in math to do this. You could invent a symbol to simplify this, right? A way to simplify this. For example, you might invent some sort of new symbol that looks like this. You might say, well, that's really equal to x to the power of 3 dot dot 2. This is your new symbol. Do you see what I'm saying?
Yeah.
Or maybe you've done another symbol like that. Okay? You create a new symbol. And what that means is whatever this power is here, I'm going to do adding, subtracting 1 from it all the way down until I get to 2. Which would mean now, if I come up with my new symbol, right, for, to 1, like this, we could define that as saying, well, that's equal to x to the 4th plus x to the 3rd plus x squared plus x. See what I'm saying? You could do that if you wanted to.
Okay. Sorry. Never mind, I'll tell you about it after the show.
Just be like,
it doesn't have anything to do with this.
I feel like we need to give you a button on the Stream Deck, but when you do it, it makes a hand come across the screen and slaps me, and I'm just like, oh man. Like that.
Actually, maybe it does have something to do with this. Okay, so I was just thinking, you know how multiplication is just addition, but a bunch of them simplified together?
Yeah.
What if, and you know how powers is that same thing, but for multiplication?
Yes.
So they're, and you know how we have a number line like this, and then a graph for multiplication, and then.
Yes.
Well, I guess this isn't really a tool we always use, but for a cube of a graph.
Okay.
It's not always used, but it exists. So there would potentially be something for powers that is like that is 2 powers as to powers is to multiplication, and multiplication is 2 addition.
Yeah. You could do something like that. So, for example, if you had like.
And then you could also go the other way. So addition is just a simplification of a bunch of another operator, but a bunch of them combined.
If we had x squared and we raised it to the 3rd power, that's equal to x squared times x squared times x squared. And we know if we have them all multiplied by each other, we do what to the powers?
We add them.
Right, so that's equal to x to the 6th.
Oh, you're right, never mind.
So, whoops, I'm right at the edge of it. It looks like x to the, can't get any more over there, so we'll just say, we're going to do that.
Yeah, you're right. We could just make the power bigger.
And what we do is we just multiply these numbers. So instead of if we're multiplying them, we add the powers. But if we're raising the power to a power, we multiply. See what's happening? So if we take something to the next dimension that you're talking about, kind of,
we would
raise the power.
powers.
Is what we would do probably. Kind of interesting. At any rate,
You're right. Okay.
Yeah, I think what we're talking about here is something like this: x to the n to some power up here. So this is affecting n. This is what you're thinking. This is the dimension you're thinking in right now, right? So we're talking about rules now that apply to these guys. If I take this, I'm not sure. I'd have to put this all out, and I multiply it by x to the n to the third, right, like that, right? I think you're talking about a rule here. Does this actually become times n to the 8th? And I can't tell if it is or not. Well, let's see. That's going to be, it's going to be x times.
You mean n to the 6th?
Oops, sorry.
Right?
X raised to the power of n squared times n to the third, which is equal to x times n to the 5th, not n to the 8th. So maybe I haven't quite figured out the dimension you're thinking in yet, right up here. It's going to take some time. My brain can't quite wrap its head around these.
Wait, why would it ever be n to the 8th? It would be n to the 6th.
Well, I was just asking the question, does the power here, right, we're talking about,
Wait. So if we take,
I should have raised this to the power of
exactly, that's what I was thinking.
That should have been to the power of something. But then now the question is the power of x, I'm not sure. I don't know if I feel like x shouldn't belong. This is something like, this is just blowing my mind to even think about this right now. I think there's a reason why humans only go up to powers for the most part when we talk about, what we can do, operators. Because I think things get a little crazy there.
But
let's start a raid.
plausible.
What'd you say?
Still plausible.
Yeah, it's conceptually out there. It's going to take some time. You're going to have to do that on your own time. I'm going to send you guys over to Lana Lux. Kelly, you want to say thanks to everybody for
Yeah, thank you. Goodbye. We'll see you next week.
We'll see you next week. We'll attempt this next week.
Yes, and the code. Goodbye.